Alright guys, so in this video we'll be continuing from where we left off. Right, so we'll be going through expectation and variance of x for continuous theta. Right. So for the street we knew that the expectation was the sum of all the x by the probability x is equal to x. And the variance was the expectation of x squared minus the expectation all squared. Right. These equations change for continuous. Why? Because for continuous, getting the probability is not as simple as before, right? Where the probability was defined under one or multiple specific or discrete points. For continuous, the probability is continuous. It's spread across multiple points, right? So in order for you to get the probability, right, you need to integrate. Because remember, the area is the probability now, right? So all the equation will turn into the x is still there, but instead of the sum, it will be the area, right? For discrete, you add, for continuous is the area, which you just integrate, right? So for discrete, you add, for continuous, you integrate, because integration will give you area under a graph, right? So the equation will just be the integral of x by f of x dx. That'll be the expectation equation for continuous. And for variance, similar to what we had, the sum of x squared by the probability x is equal to x minus the sum of x by the probability x is equal to x whole square. The equation, if you look at it, the sum and the probability x is equal to x, those just drop out and you just replace it with the integral of f of x dx, right? So same thing with this one up here. So here now we have the integral of x squared by f of x dx minus the integral of x f of x dx all squared. Right, so the trick, if you happen to forget it, the integral and the probability x is equal to x parts, and I'll just swap for the integral f of x dx. Right, so they'll just swap literally. So in this one here, the sum and the probability x equal to x, a drop, so you get the integral f of x dx. And same thing for the others at the bottom. So there's some that you can remember. Once you remember discrete, remember the continuous. That the sum and the probability x equals x is just swap for the integral f of x dx. Right? So let's try a question. So we have this piecewise defined function here, which is normally how they will give you the continuous data. And I want us to get the expectation, the variance of x. So first thing be nice for us to do is to get the PDF, which is the graph, actually plot the graph. So we'll start with our first. So we have up here will be f of x, and we have x here. And the points we have are 0, 1, because these points are smaller, space it out a little more, and 2, right? And I said between 0 and 1 is a half. And then from 1 to 2 is also a half again. All right, so that's a sketch of the data that we have. All right, so the first thing I want is the expectation. So we know the expectation of x is the integral of x f of x dx. And we integrate it. So remember integration, we integrate both pieces, right? So we have this piece here and this piece here. So turning to the integral. So anytime you have piecewise functions and trying to integrate it, you just integrate each piece separately and add them together. So this will just be the integral from 0, say to 1 of a half dx plus the integral from 1 to 2 of a half dx. Right? So we're trying to multiply that by x. So let's see how we could do that. So get ready x outside. Right, so this would just end up being the integral from 0 to 1. We put the half outside, x squared dx plus a half integral of, that's all. It wouldn't be at x squared. It would just be x. Right, so this x will multiply. You won't get x squared. You get the x squared integrate. So now this would be a half integral of x squared would just be x2 and divide by 2 between 0 and 1 plus a half x squared on 2 between 1 and 2. So this would be a half. So that'll be x squared and 2. So when you plug in the 1, you'll end up with 1 square and 2. And when you plug in the 0, you just end up with 0 plus a half. So now between 1 and 2, so it'll be top, so it'll be 2 square and 2 subtract 1 squared. And 1 will always be minus a when integrated. The b is always on top and the a is always at the bottom. So it'll be b minus a, right? So that's added here. So then this would be a half by a half, which is a quarter, plus, so it will be a half. 2 squared is 4. 4 divided by 2 is 2. And minus 1. So end up being a quarter plus a half, which is 3/4. Right? Then that will be the expectation. Now for the variance. Integral of x squared f of x dx minus the x f of x dx all squared. We already have this from before, so we just have to calculate what this is. So that'll be, so we integrate from 0 to 1 x squared, and then that will be a half I'm gonna write it. So integral 0 to 1 x squared dx plus a half x squared dx. Right? The f of x is a half and a half. When you multiply it out, you'll get the half to both of them. So this would just end up being a half by x3 on 3 plus a half x3 on 3. Now this is between 0 and 1, and this one will be between 1 and 2. Right, a little bit of maths. So there'll be 1 cube on 3 minus 0 plus a half 2 cube on 3 minus 1 cube on 3. So this will be a half of course. But 1 cube is 1. So it'll be a half by 1 on 3. So 1 on 6 Then it'll be a half. And two to the power 3 is 8 and 3 minus 1 and 3. So be 1 and 6 plus a half. So that'll be 7 and 3. So, that'll be 1 and 6 plus. So you multiply that. 7 and 6. So that'll give you 8 and 6. Right. So now we can go ahead and bring it together. So it'll be the variance x will be 8 and 6 subtract 3/4, which is squared. Calculator will be 8 and 6 subtract 3 and 4 all squared. And the calculator gave 37 and 48 as the variance. Right? So with that said, let's calculate the expectation and the variance of x for continuous theta.